Good day and welcome to Aspen Hysys tutorial by Modi Collins Obaka. Today we'll be considering understanding the basics of Aspen Hysys simulation software. I'll be making use of Aspen Hysys version 8.4. Okay, I hope you're set. I promise this class is going to be very interesting. Just sit tight and go through the video clips. You understand better. Okay, as you can see, this is the startup environment for Aspen Hysys version 8.4. Okay, but I would like to take you back to my desktop. When you have Aspen Hysys installed in your system, what you need to do next is either double click on the icon that is showing on your desktop, or you right click and click on open. Okay, as you can see, I've already opened it up, so we're going to go back to the Hysys environment. Okay, now when this is open, this particular environment where you see the recent models is usually opened. Yes, it's usually empty when you're starting it for the first time. Okay, but because of the fact that I've done a lot of work with it, you're seeing what the jobs, the process designs I've done with it. Okay, but don't be afraid when you open yours and you don't see things like this. Okay, because you've not used it before. So the first thing is opening our simulation environment. Like you see, you can't do anything on this particular platform. The PFD is not showing on the other environment, this simulation basis manager. So what do? You see this icon over here. Okay, this is new and this is open. New is used when you want to open a new case, you want to start a new project. Open is used when you want to open an old project. So you can either double click on this, or you come over to the file, click on it, and you see what's it called, new. You see open. Okay, so what do? You click. When you click, you're going to see case. Are you seeing it? So you see templates, column, and a whole lot of them depending on what you want to work on. So the first thing to do is double click on the case menu, okay, the case tab, sorry. So when you do that, it will open up to this environment. Yes, okay, you're welcome. We're about starting now. The place you're seeing here is known as the simulation basis manager, and then the next environment is our simulation environment, where the drawings, the simulation is done proper. But you lay your foundation of process design in Aspen Hysys from this environment. That is the properties environment, which is also known as simulation basis manager environment. Okay, so we're done with opening the case. All right, the next thing we're going to consider is how to add pure components. All right, to add your components, what do? You click on component list. Okay, you double click on component list. When you do that, this environment, this what's called, the tab is being opened, the dialog box, so to say. What do? You click on the add button. Okay, when you click on it, this comes out. You see component list 1. Okay, you can change the name if you wish. Okay, what do we call it? Let's call it Modi. So this is Modi's component. Okay, the name has been changed to Modi. Okay, so let's open it up so that we can add our components, our pure component first. So what we do, we double click on this. Okay, when you do this, the component list view will be opened. Can you see that? Just hold on a little. It's coming up. Okay, it's open. and you need to, okay, can you see the environment? Okay, the next thing you need to know is how to use the filter, search by, select, and search for. So we'll have the select dialog box. This is where you choose whether you need a pure component or hypothetical component. Okay, but for this particular tutorials, we are considering pure component first. Then the second one is the filter. When you click on this drop down, you're going to see all families, hydrocarbons, solid, miscellaneous, and a whole lot of it. The component list view contains thousands of components, so it's advisable to click on the component list you want to use. Say for example, as you want to work on only hydrocarbons, just click on hydrocarbons, and the only components you see on this view is what? Only hydrocarbons. Can you see it? Okay, but let's go back to all families. In all families, you're going to see both hydrocarbons, amines, and a whole lot of it. Okay, now you say search by full name, synonyms, simulation name, and a whole lot of that, and formula. Can you see it? Okay, to use a full name, all you need to do is come to this place. Let's assume you want to add water. You just type water, click on this. Okay, you type water. Can you see it? That is the full name, and the synonym is water. Okay, so if you want to use the simulation name or the formula, which is H2O, all you need to do is type H2O. Can you see it? Sorry, I typed H20, H2O. Yeah, so can you see it? All right, so when this is done, all you need to do is click on add button, and it's there. Can you see it? Okay, for now this is not what we need, so let me remove it. This is how to remove. Just click on it, or you can click water, you click on pure component, they are the same. Anyone you click, just click on remove. You see our source data bank is empty. Okay, so let's work with hydrocarbons. We're going back to hydrocarbons. I'll click outside. Okay, so let's start with methane. You click on methane. Okay, you click on add, it enters. Let's give it a minute. Okay, now let's assume you want to add from methane to say N-heptane. What you need to do is click on the first component. Okay, click on it, drag it down to N-heptane, and click on add. So that will save you the stress of adding it one after the other. Okay, with this you can add a whole lot of components. Now let's assume what you wanted to add was not N-heptane but N-octane. That's normal octane. I've already added N-heptane. What do? Click on it. You see N-octane is highlighted, but let's assume it's N-nonane, normal nonane. Okay, so you click on this, or click on what? Replace. Can you see it? Okay, click on replace. It will automatically swap the two components. Can you see that? Okay, all right, we are done with adding pure components. Now the next thing we're going to consider is how to add hypothetical components, or what is popularly known as pseudo components, false components. They are not on this data bank, so you have to create it. Okay, let's say we want to add a hypo component. You come to this select and you click on what? Hypothetical. Okay, now you see it. And now what you're seeing here is what? Method hypo group. So we are okay with hypo group 1. Okay, that's our group. So you can, if you want to create another one, you can click and then do whatever you want to do. This hypo group 1, 2, 3 is when you want to create different types of hypo groups. Do you understand? But for now, we don't want to do that. If you want to create new hypo group, all you need to do is you click on what? New hypo group, and you generate your hypos. But that's not what we're considering today. Okay, let's go straight to create and edit hypo. you click on create and edit hypo. This changes. Initially you were seeing what you're seeing there. When you click on create batch, you'll be seeing initial boiling point and final boiling point. That means the batch of hypo you want to create, let's say you want to create up to 50 hypo components, so you have to give it a temperature range, say between 30 degrees Celsius and 900 degrees Celsius. Okay, but that is not what we want to do. All we want to do is just to create a single hypo component. It's just the same thing. Okay, so let's create a single. So you create and edit hypo, that goes out. You're going to see new hypo, right? So the next thing you do is what? Okay, base properties, that's what we're using for the type. So you click on new hypo, not new hypo group. Okay, so click on new hypo. Can you see the hypo name is here? Normal boiling points, molecular weight, liquid density, a whole lot of that. All you need to create a hypothetical component is just the temperature. When you have the temperature of the component, say by analysis using chromatography or what have you, all you need to do is just get the temperature of the component and impute it. Okay, let's say we are creating a hypo component that is between C7 and C8. Okay, we don't really know the name of this component, but we know that this component exists between C7 and C8 because of the temperature range. What do? You just come to this place and write C7 plus. Okay, you've changed the name. So let's assume the temperature is 110. Okay, when you do this, all you need to do is what? Come to the, can you see estimate and delete hypo? You click on estimate unknown. Instantly it will calculate your molecular weight, your liquid density, critical temperature, critical pressure, critical volume, eccentricity for you. Okay, so we've added it. Now we're going to add it. Adding hypo component to a data bank source is the same with adding pure components. So what do? We click on add. It comes to this place. Do you understand? So that's all about adding components. All right, so after doing that, what do? You click on this, not this place. If you click on this, the Hysys environment we shut down. So we just have to click on this and we are out from that environment. You see my component list, which is a MODI, is fully defined. And then can you see it? So what we need to do is we come over to the fluid package. Sorry, I forgot to tell you, until your component list and your fluid package is fully defined, you cannot go over to the simulation environment. As you can see, component list is defined, our fluid package is not defined. So let's see, if you come to this message tab, you see required info, fluid packages, select property package and stuff like that. So we have to define our fluid package and assign the component list to the fluid package. Do you understand? I guess you do. So the next thing to do is to choose your fluid package. You know, one of the greatest challenges faced in using Asspen Hysys tool is choosing the right fluid package. You know, when faced with this particular challenge, you can either use a logical procedure in deciding which model to try first. Yes. Okay. Now, luckily for us, a decision tree was suggested by Elliot and Lyra. We'll be seeing that tree soon. So you can either use that tree or you can use method assistance. Okay, I'll show you how to use this. So first of all, let's see the tree. Okay, the first thing you need to do is what? Classify your components in your process, whether they are gases, non-polar, associating solvent, or electrolyte. Okay, if all are gases or non-polar, you try your Penn-Robinson API or your Swab-Redlich-Kwong equation of states. If it is electrolytes, you try your NRT or PISA and all of that. Now, if you have other gases apart from hydrocarbon gases, you especially those that have a pressure that is greater than 10 bar, you can use your NRT Uniquark F-hydroxane. Okay, that is when the BIPs are all known. But if it is not known, you use the Uniquark. If possible, you need to estimate your BIP from missing components only. Okay, by BIP I mean your binary interaction. Okay, but if it is polymer, you have to use soft ESD. If it is any other component that has a pressure apart from all these components that is listed, a pressure that is less than 10 bar, what do? You have to use your Henry's law. Okay, if that is not the case, use your shaft. Okay, so this tree will help you a lot. I will advise you to try and snipe this particular page for your own personal consumption. I think this will help you a lot. Okay, now these property packages available in Hysys allow you to predict properties of mixtures ranging from well-defined hydrocarbon systems, complex oil mixtures, and highly non-ideal or non-electrolyte chemical systems. Okay, all right. The second way you can help yourself out with this by selecting the right property package is to go through your method assistance. Can you see this icon that looks like a conical flask? Yes, or this. All you need to do is what? Double click on it, and you have a tab, a dialog box that comes up, switch popping out, close one. Okay, so you see, you will have to read through this so you understand later. The first thing to do is to click your next. You start by selecting one of the following, just like what Lyra did, Elliot and Lyra did. I believe they used this particular assistant to build that structure, or that structure was built, or this was built based on that structure. Either of the two goes. Okay, so what you need to do first is to either specify your component type or specify your process type. So let's say specify process. Is it an electrolyte, chemical, oil and gas processing? Let's say oil and gas processing. Is it property package description, tech dehydration, cryogenic reservoirs? Okay, let's say tech dehydration. You say you can use Penn Robinson or glycol package. So for tech dehydration, you can either use Penn Robinson, equation of state, okay, or you use your glycol package. All right, so I believe you now know how to select this. Well, I will also advise you get familiar with that particular structure I showed you earlier on by Elliot and Lyra. It will really help you to get used to the particular free package to use. Okay, like I said, the next thing to do is to, after adding your component list, is to add your fluid package. So click on your fluid package. When you click on it, this view comes out just like you did for component list. What do? You click on add. You click on add. You see a whole lot of fluid packages, okay, in Hysys. You have your acid, antoine, and a whole lot of that. So for this, you have more of hydrocarbons. Okay, for hydrocarbon systems, Penn Robinson is usually the best. Yes, it's usually the best. It's either use your Penn Robinson equation of state or you use your Suave rate quant, that's your SRK. You get it? Okay, but another reason why Penn Robinson is advised for you to use is because it accommodates a pressure range that is as high as 10,000 kilopascal. Okay, so that is why I'll be choosing Penn Robinson. So come straight to this, click on Penn Robinson, and you see we are ready to go. As you can see, here was red, that's your property package was showing red, and now it's green. So as you can see, all the messages here have disappeared, right? That means you're ready to move straight to your simulation environment. Okay, so this is where your work begins. Okay, now this is your PFD. This is where your design, your drawings, and everything is being done. This environment, that's a process flow diagram environment. Okay, so the next thing to do, as you can see, this object palette is your most important tool in Hysys. Very important. Without it, you cannot do anything, because all your unit operations are well represented here. You have your common tools like two-phase separator, you have your three-phase separator, you have your tank, you have your cooler, heater, LNG, that's a multiple pass heat exchanger, you have your heat exchanger, and a whole lot of that, and some other logical operations. So without this, you can't do anything. Okay, the next thing, if you want to go into refinery, you see all this common, you see all this columns, you have this, and a whole lot. So if this is not here, you will have problems. So let's assume mistakenly you just clicked on this button and it just vanished. You see, you'll be handicapped. So what do you need to do? Come over to this, that is under the home tab, under the modify and flowsheet tab. You see your models and streams, so you click on it. You see, our palette is back. So the next thing you need to do is just to dock it, because as it's interfering with your design, it's occupying space that is not supposed to occupy. So all you need to do is you do what? Click on any of this environment, click on it, drag. Okay, you come to this side. You can dock it to, I like docking mine on the right hand side. You can dock it to the top, bottom, or left, but I like leaving it at the right hand side. So you dock and you leave it there. I'm sorry for that. Okay, so that is how to dock your object palette. Alright, are we together? Okay, the next thing you need to do is you need to learn how to change your units to what is suitable for your design. Okay, you need it. It's very important. You know, in some cases you are expected to work with field units, or you are expected to work with SI units with some of the properties changing or thereabout, you know, something like that. You get it? So you need to define the unit you want to use, whether SI or you clone your own unit. How do you do that? You click on your home tab. Can you see this? That's a unit set. You click on it. Okay, you see a preference view coming up. Okay, units of measures. I don't mind my unit of measures. I have a lot of cloned units here for some jobs I did in the past. I'm going to show you how to clone. So this is a field unit, as you can see. Check. Okay, everything here is in field unit. Can you see it? Okay, so you have your feet and the rest, and then you click on SI. You have a lot of SI units. So let's assume, okay, you want to clone a unit. Okay, what do? You see, you have SI. Like SI is highlighted. Let's assume you want to use SI unit, but there's a particular property you want to change the unit based on what you want to do. For example, let's say your molar flow. Let's say for your design you want to use molar flow. You want to use kilogram mole per day instead of kilogram mole per hour. What do you need to do? You click on SI, come to new user, click on new user. Have you seen it? Okay, you come to new user, come over to this display unit. Okay, you come straight to your molar flow. Okay, molar flow. This is in kilogram mole per hour, so let's change it to kilogram mole per day. Where is it? Sorry. Okay, let's see. Let's assume we want to use mm standard cubic feet. Sorry. Yes, that was what I wanted to say. Okay, we'll change it to your standard cubic feet. All right, when you're done with that, your unit is already cloned for this. So what you do is because the new user is highlighted, so you can change the name.
I just want to assure you that.
Okay, you can change it from here. So you click on OK. Are we together?
Yeah.
Yes. So that is how to change your units and to clone.
What do you say?
Your unit. Okay, excuse me.
I should ask of.
Okay, so now we're going straight to adding and defining material streams. This is where your simulation starts from. Okay, this on your object palette, this is your material stream. Can you see it? And this is your energy stream. So you can either click and drop, or you double click, okay, or you come to workbook, click on workbook, and you come to this new and type 3, or the name. Let's say you want to give it a name. Let's say stream, gas stream 3. sorry, gas stream 3. Okay, all right. Now when you close this, you see the third stream. All right, now let's assume you want to, here is where you do your zoom in and zoom out. Then let's assume you want to get all your design to be centralized. This is your zoom to fit. You click it as your zoom to fit, but as you can see it's too large, so we'll use this to reduce it to what we want to do. Okay, so this is how to define. Double click on the material stream. Okay, let's change this name. This is another way to change name. Click on the stream name and type stream 1 or gas stream 1, anything you want to name it, or you can call it your grandfather's name or your name, your father's name, whatever. You know, it doesn't reject any name. Okay, so the next thing is for you to calculate, do your bubble point and your dew point calculation. See, that's your flash calculation. There are 3 properties that are very important for your flash calculation. That's your vapor phase fraction, your temperature, and your pressure. So you are not expected to define the 3 of them. When you define 2 with your molar flow, the third will be calculated. You get it? So let's say this is gas. Let's leave it at 1. Okay, for the vapor phase fraction, 1 is gas and 0 is liquid. Okay, when you have a mixed phase is 0 point something. So for your temperature, you click here. Let's assume we are working with 10 degrees Celsius. This is another way you can change the unit sets. Let's assume we want to work with Kelvin. 10 Kelvin will give you minus 273. Okay, all we need is 10 degrees Celsius, so you can leave this. Okay, so we're done with this. So what do we do? Okay, let me take this up so you can see. You know, one thing with Hysys is that Hysys is an interactive tool. It discusses with you. It's telling you that you don't have composition. So once you have your composition, you have one of the 3 properties that I mentioned earlier specified. You go straight to your composition and then you add this. Okay, excuse me. So let's assume the 0.81. we're working with assumptions, these are not real values. 0.81. Okay, 0.81. I have 0.2, 0. Okay, this is too much. The total has to give us 1, so let's say 0.1. All right, so let's say we have 0.9, so we have 0.005, 0.02, 0.04, 0.06. No, that's too much. 0.02. Okay, 0.001, 0.002, 0.002. Okay, let's say this 0.001 and another 0.001. Okay, so we are done with this. Come over to this place and click OK. As you can see, all those stores were in what? Your basis. Okay, let's see. Let me show you again. You can either change. Let's assume you want to put more fraction, mass fraction. When you click on the basis, this view comes out. From here you can choose what you want to add, whether it's more fraction or mass fraction, or liquid volume or thereabout. Okay, so that's one way you can change it. I'll show you another way later on, but let's go straight to what I wanted to show you earlier on. Okay, you come over to this. Did you notice that the pressure has been solved? Did you notice that? Okay, excuse me. Initially all we had was what? 1 for vapor telling you that it's gas. So for this gas stream to exist in gas phase at a temperature of 10 degrees Celsius, the pressure has to be what? 191 kilopascal, or within that range. Do you get it? Okay, I believe you do. So the next thing is what? Molar flow. As you can see, when I change the unit from the unit set, it affected this. So what we have here is what? ms standard cubic feet. Okay, so you come to this place, let's just type 100 standard cubic feet, and here will be turned to green, meaning that it is solved. You get that? Okay, another thing is this. Come over to the properties. I want to show you how to make use of the properties tab. These are the properties of this string. So come straight to this place. You can add new properties. Okay, you can add new properties. Let's say you click on this. This is your append. You go to gas. Can you see it? Click on gas. So let's say we want to HC dew point. That's hydrocarbon dew point. I'll click on it. That's the property we want to add. Okay, so click on this. When you click on it, you can see it has entered. So your HC dew point temperature is what? It's 10 degrees Celsius. Okay, that's your dew point temperature. That is the temperature where your stream will turn to what? Liquid. That temperature, this particular stream turns. Anything above that temperature, it turns to what? Your liquid stream or mist phase. Sorry, I wanted to say a mist phase. Okay, I believe you've gotten this. Okay, another way you can add, we're not going to define those streams. Okay, with that you can define others. Another way to define your components or to add your composition is to come to your molar flow. That's when you want to add your mole fraction, and double click on the molar flow. You see this? So those bases I told you earlier on, the composition basis, you can also change it from here. You see that? You can add, but what you're adding here is mole fraction, or you can double click on the mass flow. You have your mass fraction. Did you see that? So it's very important that you know the composition you are adding. Very, very important. That is that's very important, because once you've missed it, your simulation will be wrong. Yes, it can't give you the right answer. Do it myself and show you green, but that will be effort wasted. Okay, do you understand? Okay, let's see some things. Let's say you want to run an analysis on this gas stream. It was not in what I have for today, but let me just add it as a bonus tip. What you need to do is come to attachments. You want to run analysis on this, click on analysis, create. My time is fast elapsing. You want to check the property, point curve, CO2 freeze out, and a whole lot of that. Let's say we want to check the critical properties of this particular this particular stream. Click on it and add. Okay, you've added it. What do? You come to this place and you view. You see it? So you have your true critical point temperature to be minus 27.33, and then your pseudo critical point temperature is -4, and a whole lot of that. You can see all the critical properties. Same with envelope utilities. And yes, I would like you to play around with those analyses. If you have any question, you can ask me via the what's it called, the comment tab on YouTube. I'll be there to answer you anytime. All right, so the last part of this class, I'm going to teach you how to save your work. Yes, as in you're done with everything, and what you need to do is what? You come to this place, the file, click on file. Did you see that? You come straight to where? Save. Did you see that? So let's call it class 1. Class 1, did you see it? So I want to save it on my desktop. You save it on my desktop and click on save. So it is saved. I can now you see case blah 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 completed, saved, right? Did you see that? I believe you're seeing it. Okay. When you're done with your simulation, just come over to this place and click the close. You can minimize with this, maximize with this, close with this. It will ask you want to save the document. I don't want to already save it, so no. This environment goes off. Okay, now I saved it to my document. Can you see it? It's now here. Okay, I believe you enjoyed this class, and more classes will be coming on this. More classes will be coming on how to do your simulation with ease. Okay, I believe This foundation will help a lot when we kickstart fully. And the time is coming, we'll be running online classes, so just get ready. Very soon we'll kick off the online Hysys tutorials. I believe you enjoy it. You're not paying anything for it. It's just my own little way of giving back to the society. All right, thank you very much for your wonderful time. I remain Modi Collins Ubaka, a representative of Deacon ICT Hub and Vast Integrated Solutions. Thank you very much for your time, and God bless you.